Welcome to Smart BIM Studio.
Hello engineers, welcome to the new series of Learning Revit API Development by using Parallel Programming Strategy. In this parallel programming strategy, we'll learn both the Revit Dynamo and C# programming. Dynamo will help us to visualize the data flow, scripting strategy, and the logic building. The same script will be translated into a high-level C# programming. With the parallel programming learning strategy, anyone can master the skill of Revit API development. The strategy is not only help us to build the tools, it will help us to learn the logic building. This is a highly recommended learning process where we can see the flowing of a data, visually logic building, help the new learners to adopt the concepts seamlessly. I highly recommend to all who wants to master Revit API development, subscribing this channel and following along. There are many videos coming up in the series of parallel learning. Let's begin the series. In this video, I will take you through a simple script of and updating the fire rating of a door. Let's jump into Dynamo and build and understand the script to update the door fire rating and see how we make use of the same visual scripting building our C# programming. In this script, we'll update the fire rating of a door element that has a value. This fire rating we are going to update here. For that, we need to collect all the doors of this instance. Let's jump into it. To collect all the elements, we have a node all elements of category. It retrieves the elements of a specific categories. We are looking for this specific instance. To filter it down, we have a node filter by Boolean mask. Let filter by Boolean mask. It takes two inputs. One is the list of elements and the another one is the mask, the filter mask it needs. So to mask it, we need to follow a strategy taking element names. This is element name. This retrieves the names of the elements that is there in the project. Filter it further. List dot equal. It will check the object and with other object here. So this is the string value. So to compare the string, we need to provide another string that we are looking for. Double click here, you will get a code block. There you can write which family we are looking for. The family we are looking for is 0915 by 2134 mm. Give an input and change the longest. Now you can see here it has provided true and false value. If the name is equal with the provided name, then it will provide a true value. Other than it's false. This is the Boolean mask that this node expecting. Let's provide the data and run it. Means which has a true, that is go to in list value. the false will go to the out value. We are looking for in value. Run it. Yes, we have successfully taken the component out. We need to process this to check its fire rating value. Let's get one element from this list and process it further, identify the fire rating and update the fire rating. Take the list and flatten it, and from that list get one item. We successfully retrieved one item from it. For further process, we are jumping into a Python script. It takes two inputs. One is element and one is the input fire rating value. Let's break down. So in this script, this two lines loads Python's CLR and system libraries, how we talk to Revit API. The next thing is loading Revit services. Here we are loading the Revit services library. Document manager gives access to the current Revit document. That's the model we are looking in. Transaction manager let us safely make changes to the model. These are essential for Dynamo Revit interaction. Let's load Revit APIs. These lines loads the core Revit API and UI libraries. This is where all the element types, parameters and built-in enums live. Without this, we cannot access the things like door types and fire rating. So importing specific classes, we import two key classes. One is built-in parameters, gives us access to predefined parameters like a door fire rating and system type, help us to check what kind of a data a parameter hands, like a string or integer or a double. So here we are accessing the Revit document. This line grabs the active Revit document. It's the foundation for the everything we do, reading elements, modifying parameter, starting transactions. All of this depends on the having access to this document. Next, the key thing is unwrap 0 is the first input from the Dynamo, a door element. We use UnwrapElement to convert into a Dynamo wrap into native Revit API object. This is crucial because only native Revit element can be queried and modified and using the API. And the next line, getting the door type. Here we get the type of the door, not the instance. That's important because the fire rating parameter is stored on the door type, not on the individual door instances. We use get type ID to get the type ID and then get the element to fetch the actual type of element. Access the fire rating parameter. This line fetches the fire rating parameter from the door type. We use built-in parameter dot door underscore fired underscore rating to identify it. If the parameter exists, we will be able to read and write the value. So this is the second input from the Dynamo that we want to set the fire rating. It could be 1 hour, 2 hours or any type of string we store in the input value for comparison and potential update. This line checks does the parameter exist or not. If it is true, we move forward. This prevents errors when trying to read and write a null parameter. If it is true, then we read the fire rating parameter value by using as a string. We read the current value of the fire rating parameter as a string. This lets us compare it to new value and decide whether an update needed or not. So with the help of fire rating, let's compare and validate. This is a compound condition we are checking. Is the value not null? And is it not just a space? Does it already matches the input? All three conditions will check here. All three are true. We do not need to update anything. Value is already correct. We simply return out the output. This is useful for logging to confirming that no change was needed. If the value is missing or a different, we start a transaction, set the new value and commit the changes. Transactions are mandatory when modifying the Revit model. They ensure data integrity and prevent the crashes. If the parameter doesn't exist or isn't just a string type, we return a fallback message. This helps the debugging and makes the script more robust. Let's run and see how it's working. I'll give here the value and run it, unfreeze it and run it. Check the door value. It's 2 hours added here. Let's change its input to 1 hour. Let's run it. It doesn't change. Now it is changed. Let's check. Yeah, it's changed. In the upcoming video, we'll discuss about the C# programming of the script that we developed today. For more such content, please like, share, subscribe Smart BIM Studios.